Hello everyone, today we will be reviewing the Creality K2 Plus Combo 3D printer.
Let the game begin.
As the usage areas of 3D printers increase, our expectations from printers have also started to increase at the same rate. With each passing day, we want printers that are faster, quieter, have a larger printing area, offer better printing quality, and are smarter. The K2 Plus Combo is one of Creality's biggest steps in meeting these demands. I have been using the printer for months. Now, I have printed various printing using different materials. In this video, I will mainly show you the printing quality of the device through various examples and share my user experience. I will prepare it for the K2 Plus. In the second video, I will cover many technical details from the types of materials used in the device to the nozzle and hot-end system, how efficiently these systems work, speed tests, noise tests, and much more. But now, let's start by examining the general features of the printer. K2 Plus has a sturdy appearance. The printer's frame is made of aerospace-grade hardened cast aluminum alloy, which we are also familiar with from the K1 series, and this structure is much thicker compared to previous series. The sturdy appearance is not just due to this frame structure. The printer is quite large. Without the CFS on the K2 Plus, its width and depth are 49.5 centimeters by 51.5 centimeters. Its height is 64 centimeters. When the CFS color printing system is added, the total height increases to 91.6 centimeters. The screen is positioned at the top corner of the body, and its adjustable angle enhances ease of use. The interface of this high-resolution screen is simple and easy to use. Creality has now made this a standard, and all newly produced printers share the same interface. What makes the KK Plus a combo is the CFS, which allows us to do color printing. In other words, the Creality filament system. CFS has a total capacity of 4 filaments, and if you use a Creality filament with RFID capability, the system automatically detects what type of filament it is, and it adjusts the settings accordingly. At the front of the CFS, there is a small screen. Through this screen, we can see the temperature and humidity levels inside the system. To keep the humidity inside low, there are 2 compartments where moisture-absorbing silica gel can be placed. If desired, up to 4 CFS units can be integrated into the K2 Plus, allowing the use of up to 16 filaments on the same printing. When we look inside the printer, the first thing that stands out is, of course, the large printing bed. Currently, the K2 Plus is one of the largest enclosed desktop printers in its class, with a printing volume width, depth, and height of 35 centimeters. The movement of this large print bed is achieved by 2 servo motors located on the left and right sides, each connected to a trapezoidal lead screw and 2 rather thick steel rods. Leveling is achieved with the help of strain gauge sensors. The nozzle touches multiple points to automatically adjust the level, so you don't have to deal with any manual adjustments. In a printer with a Core XY system, the movements on the Y-axis are provided steel rods, while a steel linear rail is used for the X-axis. The tension of the belts that transmit movement here is also monitored by a tension sensor and automatically kept at the ideal level. The printing head features a steel dual-gear direct drive extruder. The filament passing through here reaches the unicorn nozzle, which we first saw with the K1C and is resistant to clogging. And with a powerful hot end system, it enables high-speed, high-quality printing. One of the key features of the printing head is the camera, which allows for automatic flow calibration. The printer draws shapes at the start of the printing in flow scenarios, and then evaluates these shapes with a camera with artificial intelligence to determine the correct flow rate and uses these settings in the printing. This helps prevent flow-related printing errors and ensures high-dimensional consistency. Another camera is located inside the enclosure. Thanks to the printer's wireless connectivity, you can send printing files remotely, monitor the printing process from afar, or even record time-lapse videos. Additionally, this AI-powered camera can detect issues such as spaghetti or problems like detachment from the print bed. It can send notifications to your phone, tablet, or computer to alert you about this situation. At high speeds, especially when using filaments like PLA or PETG, good cooling is required. For this reason, in the K2 Plus, in addition to the main cooling fan on the print head, there are powerful auxiliary fans on both sides. Additionally, it has a carbon filter to reduce odors emitted when working with industrial-grade filaments. 2 exhaust fans and a heater capable of warming the enclosure up to 60 degrees to facilitate printing with industrial filaments are positioned between these 2 fans. The K2 Plus is a high-speed printer with industrial-grade features. With all these features and a 30,000 mm per second squared acceleration, it can reach speeds of up to 600 mm per second. I had the chance to test the printer for a long time. Creality had sent me the printer even before mass production had started. And this indeed also helped to provide you with more accurate information. I did a lot of printing using many different types of filament. Now, I will both evaluate the printing, and while making these evaluations, I will also talk a bit about industrial-grade plastic types. Because as I mentioned, the K2 Plus incorporates some features of industrial-grade 3D printers. Why does the nozzle heat up to 350 degrees, the print bed up to 120 degrees? Or why is there an internal chamber heating system? We will cover all of these. But first, I suggest we take a look at the fun part. Because in addition to its industrial features, the K2 Plus is also colorful. And like all 3D printers, it's a fun printer. Let's make a quick start. Printing some test printings, benches, and so on. Let's start the review directly with a Gundam model. I think it turned out to be an important test model that challenged both the machine and me. A giant consisting of exactly 74 pieces. I had never done 74 pieces of printing just to assemble a single model as a hobby before, especially when almost all the parts required supports. If supports were used, I usually try to avoid them as much as possible in test printing. Removing the supports afterward is difficult, and I also don't like it when support marks remain on the model. But I like the model so much that I wanted to endure all the challenges. The red-colored parts here are made of PETG, while all the other parts were printed with PLA. This model, originally designed for a small 10 centimeters printing, was enlarged 53 times, and the parts that were supposed to fit tightly together ended up being quite loose. But then I fixed their movement in place with adhesive just as I wanted and achieved the beautiful result I had envisioned. Working on the model like a 3D puzzle was also quite enjoyable. I am satisfied with all the printing. Both the PETG and PLA parts turned out very well. There are only some natural surface imperfections and sagging at the support contact points. Other than that, I can't say anything negative. I printed all the parts using the standard settings in Creality Print. When you select the high-quality profile with a 0.2 mm layer height, the printing speed varies between 80 and 200 mm per second. Of course, this is below the printer's capacity. But I wanted a flawless model, and it gave me exactly that. After all, my goal here is not to conduct a speed test. It was to show what someone using the printer for the first time could achieve with standard settings without adjusting anything. Even the support settings were completely automatic. I only loaded the filament, and I positioned the parts on the build plate. That's it. Because I get asked this a lot. I'm buying a printer for the first time. Can I start using it right away? Can I learn? They ask. Of course, there isn't a single answer to this question. There's a lot to learn. You need to be familiar with different materials and settings. But now printers like the K2 Plus automate many things, and they increase our chances of learning faster and achieving better printing. Let's move on to another PLA printing. With this printing, I wanted to give you a concrete example of the printer's maximum print size. I am printing this large decorative model at a 0.2 mm layer quality using standard quality settings. The standard quality speed varies between 200-300 mm per second. At these speeds, we start to see slight vibration effects, but the overall surface quality is still successful. Since this is a model printed without supports, there are some sagging points. The sharp edges at the top also turned out well, but there is a slight amount of stringing. With a simple cleanup and some finishing touches, it will achieve a better appearance than its current state. I want to show you two more PLA printing. One of them is this mask that I used at the beginning of the video, one of the most popular series of recent weeks. The manager's mask from Squid Game. It turned out to be a very nice printing. There is nothing negative I can point out. The model was again printed using Creality Print's high-quality settings. In the other model, regardless of the inner wall, outer wall, or infill, I set all speed settings to 150 meters per second. I will use this model as a speed test model in the printing technical review video, taking a closer look at the technical specifications of the K2 Plus combo. In that test, you'll see model versions printed at 50, 300, and 600 millimeters per second. I noticed slight vibration effects at certain points of the yellow filament. Other than that, there is no issue. In fact, I can say that the black part in particular is flawless. Now, I would like to give some information about the CFS system. After that, we will look at the printing I made with industrial filament types. CFS is not very different from brands that have previously used a similar system. The color changes look good, the system is working well. However, it increases the printing time and there's also a lot of filament waste. Let's take a look at this through some examples. The toy you see was printed using 3 different colors. The color transitions are nice and there are no mixed colors. The printing quality is also quite successful. There are only some slight drooping issues in the bow tie area. Other than that, I don't see any errors. A printing made using Creality Print's high-quality settings, when we look at the amount of filament used for this printing, which took a long 15 hours, you might be more surprised by the filament consumption than the printing time, because while the toy itself weighs only 50 grams, the filament wasted during color changes amounted to 230 grams. That's almost 5 times the weight of the model. Is it reasonable to print a single model? Definitely not. The print time is too long and the filament waste is too much. However, for example, you can place at least 20 of this model on the same printing surface. So what changes? The amount of waste from color changes remains the same. This means that with 20 printing, the waste per unit drops to just 11.5 grams. As for the printing time, the time per unit decreases from 15 hours to 3.5 hours. So when printing multiple copies of the same model, you can utilize it almost as efficiently as if you were printing without color changes. Let's take a look at this model here, a Deadpool bust. Even though it is smaller than the rabbit model, the printing time took a full 24 hours due to the high number of color changes. A long 24-hour printing. Apart from a small line at 2 points, there were no issues. The color transitions are nice. The printing quality is also quite successful. If the printing had been in a single color instead of multicolor, the printing time would have been reduced to just 2.5 hours. So I think I understood the logic, and I believe I was able to explain it to you as well. With color printing, the more of the same model you have on the printing bed, the greater your advantage. Of course, the printer's large printing area also provides an additional advantage. The printing is a functional model. At least for me, it is a simple and stylish stand for an Xbox controller. I was quite satisfied with this 10-hour printing. The printing quality is nice and it's also compact. However, I did not encounter any issues with frequent color changes. During the 10-hour printing, the CFS system only left a small amount of waste filament inside. Other than that, it didn't cause any issues. There is a slight amount of stringing between very fine lines, but it can be cleaned up in seconds, even with a lighter. Honestly, the CFS system made me a bit uneasy, because I had heard complaints about layer shifts occurring. I had watched a few videos about this. I haven't encountered such a problem yet. I will conduct longer tests in the technical review. However, I must say that there is a significant difference between the one I used initially and the current K2 Plus. In the past 3 months, both the K2 Plus and Creality Print have received numerous updates. And I can say that after each update, I started getting better results. In its current updated state, I think everything is going well. Yes, now with some industrial-grade filament types. Let's see how the K2 Plus performs. The first example is ABS, a part that can be used directly on the K2 Plus. The designer has slightly modified the part on the printing head. The two printing are quite nice. ABS is a type of plastic that does not like airflow because it can warp very easily. The printing can separate from the build plate or cracks in layers. Since the K2 Plus has a closed case, it's already ideal for ABS. But additionally, with the internal chamber heating, none of these issues occurred. It adhered to the print bed very well, and the surface quality is also quite good. I only see slight waviness at the very top points. Other than that, I can't say it is. Since ABS is a material with high heat resistance, it is suitable for surfaces, very suitable for direct use on surfaces. ABS is not an easy material, but there is an even more challenging one: polycarbonate ABS. Polycarbonate is an additive that enhances both the heat resistance and mechanical properties of ABS, but at the same time, printing with it becomes more difficult. For that reason, when using polycarbonate ABS, having a closed frame printer with internal heating is an advantage. I made the necessary adjustments and even sprayed a bit of hairspray on the print bed to achieve this printing, you see. The reason I used hairspray was to make adhesion easier. I didn't encounter the slightest problem. I achieved a very successful result with minimal sagging at sharp angles without experiencing any adhesion issues on the print bed. If I had to mention a minor issue, I would say that nozzle marks appeared on the top layers. Let me add one more thing. It adhered to the print bed so well that I attribute this partly to the internal heating of the enclosure. A portion of the brim I created around the model for better adhesion remained stuck to the printing bed. One of the main reasons for this was the nozzle. At that moment it was too close to the print bed. One of the criticisms to the printer is this: the table leveling system doesn't work much differently from the K1 series. Sometimes it levels very well, sometimes it stays a bit too close, and sometimes it is a bit too far. But with the latest updates, they have largely resolved this issue. For about a week to 10 days, I haven't experienced any issues with bed leveling in my printing. I made things a bit more challenging and conducted 2 tests with PA12 nylon filament. Nylon is one of the most commonly used materials for industrial-type functional 3D printing. The layers fuse well, it is flexible, has high temperature resistance, a low friction coefficient, and is a very strong polyamide. Therefore, it is ideal for parts that require fatigue resistance and for components like gears that experience constant friction. Printing, however, as I mentioned earlier, is very difficult. The biggest issue is adhesion to the print bed. Once again, by using an enclosed heated chamber and applying hairspray to the print bed, I was able to achieve the printing I wanted. One of them is the gear you see here. The model printed successfully. There was no warping from the print bed. To demonstrate how well the layers fused together, I deliberately did not cut the surrounding brim I created. Even removing the brim from the model is quite difficult. This material also has good fatigue resistance. In other words, no matter how much force is applied to a part, even pressure, it still maintains its structure. A shock absorber is a good example of this. It was a tough material and a challenging model. There were many supports on it. However, I was able to get the printing I wanted. In fact, I also did the printing of the other parts of the shock absorber with ASA filament. However, I couldn't assemble it due to a scaling issue, because this model was actually designed to be a keychain, and when I changed the scale, the parts no longer fit together. But functionally, it makes sense, because ASA is a material with high resistance to both heat and ultraviolet light. If such a shock absorber is to be used outdoors, these two materials can be preferred and used in combination. ASA is also a more difficult material than ABS. Since we don't use cooling, it's natural to have sagging at right angles. And that was the only issue I encountered. Other than that, I was able to get the printing of all 3 parts smoothly. I want to show the second print I made with ASA. Both second printing are functional parts. One is an attachment designed to create a bistro table. The other is a part that can be used directly on a tripod. Both printing have a nice surface quality. And just like the previous printing, there was no warping from the print bed or any surface issues. I clearly felt the benefits of the internal heating system in all these printings. I had never used a 3D printer with internal heating before. To be honest, I thought it wouldn't be that necessary. I assumed that since the print bed heats up, it would also provide internal heat, but that wasn't the case. Many of these filaments are not easy to use. Sometimes, even if you have an enclosed 3D printer, you can still encounter problems. However, internal heating makes things much easier at this point. Now let's move on to the printing I made with TPU. TPU is a flexible type of filament and is especially used for electronic device cases, or functional parts are frequently made with it. I also made 2 different printing in line with its intended use. One of them is a phone case. There is slight waviness in some areas because the wall thickness is thin, but other than that I am satisfied with the printing quality. I did this printing for my own phone and it turned out to be quite usable. The other printing is similar. I have a new camera, DJI Pocket 3. I took a printing of a mount to keep it stable on the desk. The surface quality is nice. I especially like that there are no nozzle marks on the top surface. TPU is a type of filament that can be used for printing on open frame printers. The important thing is a direct drive stable extruder. And the K2 Plus is one of the printers where you can easily use TPU material. Carbon fiber reinforced filaments have been around for a long time, but after the K1C, we started seeing these materials more frequently. Because carbon reinforced filaments deform printing nozzles very quickly, they cannot be used with these nozzles. However, printers that use hardened steel nozzles can handle them. Creality came up with a great solution after the K1C. With the new unicorn nozzle, it not only benefits from printing thermal conductivity, but also prevents wear with the hardened steel nozzle tip. I was able to get printing using carbon fiber PTG on my printer. These are attachments that you can mount on the exhaust fans of the K2 Plus. By mounting these on the fan outlet, you can use a spiral hose to vent the harmful gases emitted by industrial filament types outside your environment, or connect them to an air purification device. As for the printing quality, a single line appeared on one layer in one of the models. Other than that, not the slightest. Both printing turned out quite successful. You can also see the printing I made using carbon fiber PLA right now. I took the printing of various bolt and nut models, furniture joints, or tool components. The carbon fiber additive provides extra durability to the material, and it made sense to use carbon fiber infused filament for all of these models. So I printed them. I am very satisfied with the surface quality of each piece. There isn't the slightest issue in any of the printing. I don't see any problems at all. In the end, the K2 Plus combo delivers good printing quality, a nice printer with a large print area whose color filament system works good and, more importantly, can handle industrial filament types well. When I first started using it, I had some doubts in my mind. However, Creality continuously improved the printer with updates, always taking it a step forward. And right now it works quite well. The CFS system is selective with filaments. It doesn't like cardboard spools or lightweight plastic spools. However, it works flawlessly with other Creality filaments that don't have cardboard spools. The CFS shouldn't be thought of as just a system for printing in color. For example, if a single spool of filament won't be enough for your printing, you can load multiple filaments, allowing the printing to continue with the next one when the first runs out. Another important use case is that this system allows you to easily use support filaments like PVA or HIPs. The K2 Plus is much quieter compared to the K1 series. Increasing the number of auxiliary fans from 1 to 2 in the K1 series was a smart move. This not only reduced noise but also improved efficiency by providing cooling from 2 points. Large printing area. While this is generally an advantage, it becomes even more beneficial when printing a large number of multicolored printing. The printer is very large and heavy. I don't recommend moving it from one place to another by yourself. Even when I tried to reposition it a couple of times within my home, I struggled quite a bit. In my opinion, if you're considering the K2 Plus solely for hobby use, it's a luxury printer. However, if you're choosing it for industrial or professional use, it's ideal. The price isn't cheap, but as far as I know, there isn't another printer in the same price range that can printing in these sizes and has these features. Creality is still the world's largest printer manufacturer. However, it also needs to keep up in terms of software. I can see that they are paying more attention to this based on the updates they bring to both the printers and the slicing software. But I also want to mention that I expect even more. Let me tell you this, I think I am one of the people who has used this printer the longest, aside from Creality's engineers. And as of today, I am satisfied with the printer. I recommend it to you. I hope this video has been useful for you and has given you some insight. So what do you think about this printer? I'm looking forward to your comments. I'll be preparing the K2 Plus combo. Stay tuned for the technical video. May your printer run smoothly and your printing be flawless. See you in the next video. Goodbye.